Welcome to the new Project Lead the Way's POE Introduction to Thermodynamics 1.1.3. Okay, today we're going to talk about thermodynamics. So if you rub your hands together for 15 seconds, you're going to feel something. It's going to be heat. That's thermal energy. Now, thermodynamics is the study of heat. Thermo stands for the Latin for heat. Dynamics means motion. So it's the study of how heat is in motion. So it's talking about the flow of heat or the flow of energy in a system. A system is anything that we're looking at. It could be the rocket ship. It could be the rocket ship and the fire. It could be the nuclear power plant. It could be just the nuclear core of that. It's what we're looking at specifically. So, and then we ignore everything around it. That's just the surroundings. We don't care about anything else. The thermal energy, though, is versus temperature are different, okay? Thermal energy is the kinetic energy. It is dealing with joules. It's an energy unit. While temperature deals with the average kinetic energy, and it's measured in degrees. They're completely different things. Now, temperatures can be measured in Celsius, Fahrenheit, or Kelvin. The important one that you need to know is that 0 Kelvin is negative 273 degrees Celsius. 0 degrees Celsius is the same as 32 degrees Fahrenheit, which is the same as 273 degrees Kelvin. Boiling water are these. Thermal equilibrium is when an object touches another object and it transfers all of its heat, and they're both at the same heat temperature. So they are going to be, they're going to transfer that heat. So the zeroth law of thermodynamics states that if object 1 is in thermal conductivity with object 2, and object 2 is in thermal conductivity of 3, 3 and 1 are also in equilibrium with each other. So that's A equals B, B equals C, so that means that A and C have to also equal each other. Now, there's ways of transferring energy: convection, conduction, and radiation. Convection is the movement of materials. Conduction is touching the object, and radiation is through light. None of it is 100% efficient. And all these processes are irreversible, meaning you cannot stop them. Once they pass their heat on, you can't just suddenly say, no, please go back. It just doesn't happen like that. You cannot package all that energy back into an atomic bomb. It will just go on. Okay? The first law of thermodynamics states that the energy cannot be created nor destroyed. It can only be transferred from one area to another. You can transfer it from chemical energy in the wood to fire. It can be from electricity to heat. It could be from the nuclear bonds in a nuclear bomb and releasing it into kinetic energy and thermal energy. It can be any form. So you can see an example of this. Pumping the handle results in what? Well, it's going to cause air to move. That's mechanical energy. But it's also going to increase the heat because you got that friction going on. The second law of thermodynamics states that energy is going from the heat's going from hot to cold. So it's the ice cubes aren't melting. It's actually the heat of the water going into the ice cubes that are actually melting it. So when you touch a frozen pizza, what's the direction of the flow? That's going to be hand to pizza. So when you touch the hot pizza, what's it doing? It's going to go to the pizza in the hand. Now, entropy is measured how heat in a system is going to go from something orderly to disorder. The molecules are very ordered. They're going to be very nice and pretty, but when you burn it, it's suddenly going to release. They're going to go into disorder, and this is always going to happen. You cannot just take ash and reorder it back into wood. It's not possible. Convection, again, that's just movement of the liquids and gases in a fluid. Conduction is touching, so physically moving. So it's touching the spoon, who's touching the liquid. Now, here's the first equation. I want you to write this down. Q is equal to mc delta T. We call this the MCAT equation. mc delta T. M stands for the mass of the object. C is specific heat. That means it's how much heat can it hold on to. Some things can hold on to heat very, very well. Some just don't. Delta T is the change in temperature. Triangle here, delta, stands for the change in temperature from when it heated up to cooled off, or vice versa, from when it's cold to heating up. Q stands for the energy. So that's the energy of heat, measured in joules. Here's your other equation. Power is just the heat over time. So it's power, how much heat is transferred from one place to the other. So power can also equal K, which is the thermal conductivity, times its area, times its change in temperature, divided by the thickness of the material. Or rearranged, this is just solving for K of this exact same equation. So now we're going to look at this, calculating the energy transferred from when a block of aluminum at 80 degrees Celsius is placed in 1 liter of water at 25 degrees. What's the final temperature? The first task is to list all our knowns. So we know the mass of the water. It's at 1 kilogram. What's the specific heat in water? Well, I look it up on a chart, and it's going to say it's 4,184 joules per kilogram degrees Celsius. Changing water, well, I look at my water. It started at 30, went from 25 to 30, so I changed that, and that's 5 degrees change. The specific heat of aluminum, again, I'm going to have to look that up on a chart, and that's going to say it's 900. Then we have finally our change in temperature. It went from 80 to 30, so that's a 50 degree change. Now, we're going to list all our unknowns. We don't know what the heat is, and we don't know the mass of the block. So we're going to first solve for the heat. Do the Q equals MC delta T, where C is that 4,184. All right. That is going to be 1 times 4,184 times the 5 degrees change. That's 2,100 joules gained. Now we know that the aluminum is losing the same amount of heat as the water is gained. So that same 2,100 joules is actually going to flow into the water. So the water is going to gain that same amount. So we can look at the aluminum. The aluminum, we know it's going to be the same. Its Qs are going to be the same. So we can put the 21 here, 2,100 joules. We know C's specific heat is 900, and we know the temperature difference was 50. So we plug those in, rearrange the equation, and solve for mass, and we get a grand total of 0.46 kilograms. And that is the end. Thank you, and have a great day.